Good day, everyone. And once again, your favorite uncle is back. And thank you for joining us. And this time we'll be looking at question 3, which is based on vertical projectile motion. So if you haven't subscribed, please just make sure that you're part of the family. Hey, Mlungisi Nkosi will continue to be your plug when it comes to mathematics and physical science. All right, and of course, if you need to get in touch with us, our email address is info@mlungisinkosi.co.za. You can also see it on our bio, so it will be attached there. And by the way, now you've got an option called Super Thanks. If you really want to show gratitude for the lessons, you can just, hit that Super Thanks button, and you can donate any amount of money that you want to just say thank you to your favorite uncle. All right, now let's go into the question. They say we've got a small disk C, which is thrown vertically upwards at a speed of 15 meters per second from the edge of a roof of a building of height 30 meters. They say after 0.5 seconds, please note that. Okay, so after 0.5 seconds, a small ball B is shot vertically upwards from the foot of the building at a speed of 40 meters per second in order to hit disk C. They say ignore the effects of air resistance. So in this case, of course, they are telling us that it is obviously moving as a projectile, or rather under projectile motion. This case where gravity is the only force that is acting. Okay, right, now they say explain the term projectile. So we know that a projectile is something that moves in the air. Okay, obviously we can also state that it's moving under the influence of gravitational force. Okay, and 3.2, they say calculate the time taken by disk C to reach its maximum height. Now, what I want us to do, ladies and gents, I'm just going to try and redraw this structure or the building here. Okay, so if we've got a disk here, we know they threw it upwards. It reaches maximum height, went back down. This is the point, the same point from where it's departed from. So in this case, up until that point. So I want to call this point P, and that point Q, point R, and point S. This is just solely looking at the disk. Now they wanted us to calculate the time until maximum height. So we are going to look at the points between P and Q. So let's gather all the information that we need. So from P to Q, what is our initial velocity? Now, before I forget, remember that when it comes to projectile motion, please always choose a positive direction. I'm going to take upwards as positive. In this case, it doesn't really matter. Even if you took downwards as positive, you still are going to end up at the same point, right? So in this case, I'm going to say, well, I've got initial velocity, which is positive 15 meters per second. Final velocity, which is 0. Remember that when it gets to maximum height, it stops momentarily, right? So in this case, we say our final velocity is 0 at Q. And then gravitational acceleration, that's minus 9.8. Remember, ladies and gents, that for every position where the ball is, remember that gravitational force always acts vertically downwards. Now, because we've taken up as positive, that is why the value for our gravitational acceleration will remain negative for all the questions that we are going to answer. So it doesn't depend on the direction of motion, but in this case, it depends on your choice of positive direction. So we wanted to find the time. Are we given displacement? No, we don't. So in this case, we're simply going to say, well, we're going to take the only equation because we're looking for time. All right, so we're going to choose an equation with time, but we don't have displacement. So in this case, we're going to choose the only equation without displacement. So that equation is VF is equals to VI plus g delta t. Right, so we're going to say our final velocity is 0, our initial is 15, plus a negative 9.8 times delta t. Okay, take that to the other side. That's minus 15. That's minus 9.8 delta t. And we can divide both sides by minus 9.8 or negative 9.8 in this case. And delta t, right, I've got my calculator here. Okay, let's see. So that's, of course, we know negative divided by negative is a positive. So I'm just going to say 15 divided by 9.8. And that will give us 1.53 seconds. Okay, so there's our answer for the time that it takes till maximum height. All right, next question. They say calculate the maximum height above the ground reached by the disk. So the maximum height above the ground, in this case, we are now going to look at, now by the way, sorry for not numbering, this is 3.2.2. Okay, so this was 3.1.1. Sorry, 0.2.1 rather, and this is 3.2.2. Right, so we're still looking at the same set of information. However, now please keep in mind that this ball, or rather this disc, was already 40 meters, rather 30 meters. The building, the height of the building is 30 meters. And it went a further distance to reach its maximum height. Now, what are we looking for? We're looking for that total distance there, right? So I'm going to look for the distance from where it started from up until that maximum height. And of course, I'm going to add it to that 30 so that we get that total distance there, right? So I'm going to use an equation that will avoid me using this time that I calculated myself, okay? Just to avoid any error in case I got that wrong, so that I don't make another, I don't get another wrong answer. So I'm gonna use VF squared, VI squared plus 2 times G delta Y. The only reason I'm using it because it doesn't have time. So we know our final velocity is 0. Our initial, we said it's 15 squared plus 2 times, that's minus 9.8 delta Y. And in this case, if I take that to the other side, it becomes negative. So that's minus 15 squared is equal to 2 times 9.8. That will be minus 19.6 delta Y. And we can divide both sides by minus or negative 19.6. That's negative 19.6. Okay, right. So we can actually just get that value from the calculator. Again, negative divided by negative is a positive. So I'm just simply going to say 15 squared. Okay, and I'm going to divide that by 19.6. And I get 11. So our delta Y value is 11.48 meters. Now, please keep in mind, we did say that, so it means that the distance from here till there was 11.48 meters. But remember, it was 30 meters above. So in this case, we are just simply going to add that to get the maximum height, right? So the maximum height would be 30 plus that 11.48. And in this case, it would be 41.48 meters. Okay, please just keep in mind that even if you had taken down as positive, that would have come out as negative, right? But please, 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 under no circumstances are you to say now it's 30 minus that 11.48. We are going to take the absolute value, meaning that we are going to disregard the negative. We're going to still take 30 plus that 11.48, even if it came out as negative. Okay, right. I hope that makes sense, ladies and gents. Right, going to our next question. So they say to us, calculate the time from the moment that disk C was thrown vertically, was thrown upwards until the time ball B hits the disk. So, In this case, it means that, so here is the disk. As it goes down, let's say it gets to some point, let's call that point X. All right, but in this case, we also had released the ball, and let's assume that they collide when they get to this point X over here. Now, ladies and gents, I want you to please listen carefully. Okay, so now from the point of throw, which is here of the disk, right, up until it gets to this X position here, right, I want you to please consider in this case that the total displacement will be, right, remember from here it went 11.48 meters upwards, but then it went 11.48 meters downwards, 48 meters downwards. So it was displaced up and then downwards. Then it means the total displacement between that point P and that point, so that's PQR. So between P and R, the total displacement is 0, right? So it means that the only displacement that we'll consider will be, let me just draw that in another color. All right, let me just use the green. So in this case, the total displacement from beginning to end will be that green portion for the ball, okay, for the disc rather. Okay, now, on the other hand, for the ball, now remember, this is the height of the building, and we remember that that height is 30 meters, isn't it? Okay, now, if I'm going to do something here, I'm going to consider the displacement of the ball going upwards, right? In this case, let's just say for argument's sake, it is displaced an X amount, or, you know, whatever you want, D. Okay, in fact, let's use a different symbol, right? Let's use D. Let's say it was displaced an amount of D, right? So I want you to please note, in this case, let's start with, we'll come back to that ball, right? So it means, what would be the displacement? Now remember, of the displacement of the disk. The displacement of the disk, remember we said it would be from there till there, that point which is X. But how far would it be? It would be 30 meters minus that point, D there. So it means that, okay, this will be 30 minus D. So it will be displaced 30 minus D. Okay? Right. I hope, ladies and gents, that makes sense, right? So now let's look at the ball. Okay? I'm going to start with the ball, which was projected from the ground. So in this case, what's our initial velocity? Our initial velocity is 40 meters per second. It's positive because it's going up. Okay, so our final velocity at point X, we don't know, right? So this is from the ground up until X. So this is from ground up until that point X. But we do know that gravitational acceleration, that's still minus 9.8 meters per second squared. We know the time that it takes. Now, let's just consider, for argument's sake, for the ball. If we were to take the time for the disk from the point of throw up until it gets to that position there, if we are to take that time as Tx, how long would it take the ball from that time till there? Remember that the ball experienced a time delay of 0.5 seconds. So then it means, if I'm going to take the time for the for the disk from that point of throw up until point X to be Tx. Okay, let's say it traveled for a time called Tx, or you can call it Td, whatever you want to call it, right? So in this case, it simply means that then the time for the disk would therefore, for the ball rather, would be Tx minus 0.5. Okay, I hope that makes sense. Right, and then obviously for our displacement for the ball, in this case, we said it was displaced upwards by d meters. So I'm going to leave that as positive d because it signifies direction upwards. All right, now we can use our equations. Because we don't have final velocity, the only equation without final velocity in this case, we're going to say delta y is vi times delta t plus 1 over 2 g delta t squared. So that's going to be d is equal to 40 times tx minus 0.5 plus 1 over 2 times minus 9.8, negative 9.8. Sorry, because I'm going to run out of space there. That's tx minus 0.5. Okay, you know what, for the sake of space there, what I'm just simply going to do is, right, so let me just write it at the bottom there, okay, so that it does not interfere with what we're doing. Right, so in this case, we said our displacement is going to be d. Our initial velocity, that's 40 times tx minus 0.5 plus 1 over 2 times negative 9.8, and in this case our time was tx minus 0.5. So that's the time that it takes till x. Okay, if you want to, you can just simply simplify that, and you get 40 tx, I think. Okay, minus 40 times 0.5 is 20, so that's minus 20. Okay, and half times 9 minus 9.8 is minus negative 4.9 into, now if we expand that, remember you have tx minus 0.5 into tx minus 0.5, right? So that would be tx squared, okay? And then you've got tx times negative 0.5, which is minus 0.5 tx, but you've got another minus 0.25 tx, which gives us negative 1 tx. So that's negative tx, okay? And plus, in this case, remember negative times a negative, plus 0.25 in this case, right? And we can simplify further. That's 440 tx minus 20. That's minus 4.9 tx squared plus 4.9 tx, okay, minus now 4.9 times 0. So that's 4.9 multiplied by 0.25, and I get 1.225. So that's negative 1.225. Okay. Right, so that's our value for d. So let's try to just write it nicely. So that's minus 4.9 tx squared. So I'm taking this one. Okay. Like terms there, that's 40 tx and 4.9. So that's plus 44.9. Okay, tx. All right, and I'm going to have negative 20 minus 1.225. That would be minus 21.225. Okay, sorry for that very ugly way of writing it there. So let's call that equation 1. Okay. Let's call that equation 1. Now, let's go for the, for the disk. So now we're talking about the disk. And we're saying as the disk falls, now please I want you to keep in mind, we said it was displaced, right? 30 minus d. But you must keep in mind that it was displaced downwards. So in this case, what it means is that that displacement for this guy will actually be minus 30 minus d, right? So for the initial velocity, we know that the disk from where it was projected was 15. Final velocity, we said we do not know it. Gravitational acceleration, that's negative 9.8. And the time that it took, remember, we did say that, from where it was projected from up until that point x, we assumed that it took a time of tx, right? So it would utilize that full tx value, whereas for the ball, it was minus that 0.5. And then we say, well, what is our displacement in this case? Now, please remember, we said it's 30 minus d. That's the distance. However, remember that we chose up as positive, so it means downwards would be negative. Okay, now let's write an equation for that guy there. Okay, taking the very same formula, delta y is equals to vi, delta t plus 1 over 2 times g delta t squared. So let's just substitute there. So that's minus 30 minus d, okay, which is equal to now, that was 15, right? So that's 15 times tx plus 1 over 2 times negative 9.8 times tx squared. All right, so I've got minus 30 plus d, which is equals to 15 tx minus 4.9 tx squared. All right, I'm just going to isolate d there so that it's easier for us. Again, it's minus 4.9 tx squared, okay, plus 15 tx, and I'm going to take the 30 to the other side, that's plus 30, okay, and let's call that equation 2. So, because both equations, equation 1 and equation 2, are both expressions of d rather, so I'm simply going to say, well, it means that equation 1 is equal to equation 2. So I'm going to take the right-hand side. So equation 1, let me just be careful there. That's minus 4.9 t squared plus 44.9 tx. So that's minus 4.9 tx squared plus 44.9 tx. Okay, I think we had minus 21.225, which will be equal to, now let's just check if we are correct. Plus 44.9 minus 21.225. Yeah, I think we are correct. And then on the other hand, on equation 2, we've got minus 4.9 tx squared plus 15 tx, okay, because of space there, plus 30. Okay, sorry about that. All right, so now remember they are both next to an equal sign. So what I'm going to do is I can just cancel those because they are exactly the same. So that's 15 tx and 44.9 tx. So that would be 44.9 tx minus 15 tx is equal to, now I'm going to take this to the other side, okay? That would be 30 plus 21.225. Okay, so let's just find our final answer there. So we've got 44.9. Okay, 44.9 minus 15, and in this case that gives us 29.9 tx, which will be equal to 51.225. And of course we can divide both sides by 29.9. Okay, and to get the value of tx, we just simply, let's clear that. So that's 51.225. No. So 51.225, and we divide that by 29.9. And I get a time of 1.713, well, 1.71 seconds. All right, please just verify, ladies and gents, just check if I'm still on the right track. Okay, so that is how we were going to answer that question. Okay, right, just please make sure that my approach was correct. Just verify that answer. And then finally, they say to us, draw a set on the same set of axes, sketch graphs of velocity versus time of for disk C and ball B from the moment that disk C was thrown upwards until ball B hits disk C, right? They say label the graphs for ball B as B and for disk C as C. All right, so let's do that quickly. All right, so remember that when you draw a velocity time graph, so first of all, please always remember to label your axes, right? So this is velocity, that is in meters per second, and this is time, this is in seconds, right? Now, let's talk about the disk. So we know for the disk, it started at 15 meters per second. So these are our axes. Let's show that. Okay, at 15 meters per second. And what happened? As it went up, it decreases. And then the velocity starts becoming negative as it goes down, right? So it's minus 15. And in this case, we remember that it reached maximum height. And what was that time for maximum height? We did calculate it. That time was 1.53. Okay, so it reached maximum height at 1.53 seconds. And then at 1.7 seconds, 1.71, this is where it collided with the other ball, right? Now, I want you to please note for, so this is for ball, so this is for C, right? This is for C. Now remember, sorry, this is for the disk, for disk C. And then for ball B, remember that we started after 0.5 seconds. So we're not going to start right at the beginning at 0. We started after 0.5 seconds. And what's going to happen? It's going to decrease in velocity. Now, I want you to note in this case that it's also going to end somewhere. So this would be the graph. Ooh, sorry for those wobbly hands there. Okay, so it means those are the two graphs. It's going to end at 1.71, and in this case, that is how our graph is going to look like. And by the way, I need to indicate that is 40 meters per second. That is 15 meters per second, right? And in this case, they are decreasing as they go up, all right? If you had chosen down as positive, obviously, you would have a positive gradient for both of those graphs, okay? I think that is how the cookie crumbles. A very interesting question. I hope that you have been able to gain quite a lot in the little time that we've spent together. And please, ladies and gents, we now have super thanks. So you can just decide to bless your favorite uncle, or tell your parents, right, to just bless him and just contribute, because it will help us a lot to making sure that we produce this quality content all the time. So I just want to leave it there, and I'll see you guys next time. Sharp, sharp.